Hi everyone, this is Kona, and in the video that I made where I talked about how to do the simple linear regression in Minitab, I talked about you have to make sure that the four assumptions of the simple linear regression are met in order to move forward and use the data. So this is where I'm going to actually talk about these four different assumptions and how you can check them. I had on the previous video how to actually get these types of graphs in Minitab, but then this is how you would actually go through and understand the graphs. You also have a quiz on this, so it's important to understand not only to better understand the residuals and simple linear regression, but also you do have a quiz on it. So the first one is linearity. This is checked from a scatter plot of the actual data, and you check to see what type of correlation the scatter plot appears to show, so whether it's positive, negative, or none. If it's positive or negative, then you're good to use this data for a linear regression. If it's none, so if there is no actual linearity there, then you will not be able to use this data for a linear regression. So in this first example, see how the data is kind of all over the place and there's no real rhyme or reason what's going on? That one, it would be none for type of correlation, and you would not be able to use this for a linear regression. In this example over here, it's actually a negative correlation. So see how the data all kind of follows along that line of best fit, and it has a definite negative correlation pattern. So that means that you could use it. So it's a negative correlation, and you could use the data for a linear regression. But we have to check our other things, our other examples. So equal air variance. This is checked from a residuals versus fit graph. This is not a graph of the data, but a graph of the residuals from the data. So you remember we talked about residuals and what residuals were. So for here, we've got the residual value and the fitted value. So that's what it's kind of showing. And so what you're checking to see if the residuals form a pattern. If there is a pattern, then you do not, then that means the data is not random, then you don't want to use it. So if there's no pattern, so it is random, then you are good to use the data. So in this first example, there's no real pattern, no real rhyme or reason of what's going on here. So that means no pattern, which means we are good to use this data for linear regression. If you come over and you look at this example, there does seem to be a pattern right there. So in that case, you would want to say there is a pattern, doesn't appear to be random, and I do not want to use this for our linear regression. So hopefully that kind of makes sense there on no pattern is good in this case, pattern is bad. So no pattern good, pattern good. Or no pattern good, pattern bad. Up here, no correlation is bad, having a correlation is good. All right, so now for the independent observations, this is also checked from this same graph above, or these same figures. So it is checked from the residuals versus fit graph. This is not a graph of the data, but it is of the residuals of the data. And what you want to check to see if there is a correlation. So if there is one, positive, negative, or none, then what you would do is decide if there's no correlation, then you're good to use the data for the linear regression. So in this case, looking at this one, and the equal air variance, it's, well, let's see. Do you think that there's any correlation here? Yeah, no, I really don't see any correlation. So it would be none, and if it's none, no correlation, we're good to use it for the regression. So for this one, we'd look at it here, and honestly for this one, I don't really see a correlation here either. So it's like, no, not really a correlation. So in this case would be none, but remember you have to meet all four of these. So just because this one, you would say, no, it doesn't look like there's a correlation. So that's good, but if you were up here or over here and you're like, oh, but there's no correlation here for the regular data, you wouldn't be able to use it because this one's a no and this one's a yes. So you have to have, everything has to fit with being able to use it. So all four of these have to fit with being able to use it for the linear regression. Otherwise, you can't use it. So coming down here, the next one is normality of errors. This is checked from a normal probability plot. Once again, not a graph of the data, but a graph of the residuals. So normal quantities and the residuals. I will say that when you get this in Minitab, you will not get these little dashed lines. You just get the little dots, which are your actual plots, and you'll get the line of best fit. You will not get the two outside lines there. But what you're looking for here is to check to see if the data appears to be normal, yes, normal, or no, not normal. So the closer the dots, the residuals are to the fit line, the more normal they are. If the residual data looks normal, then you're good to use it for the linear regression. So in this case, see how all of the dots, I mean, other than a couple of them, but most of the dots all fall pretty close, if not on the line. So yes, this does appear to be normal, and we're good to use it for our linear regression. In this example, see how you've got a lot of different points, a lot of different little residuals that are not anywhere close to our line. So in that case, we would say no, the data does not appear to be more normal, and it's not a good fit for the linear regression. So something else to think about, here you've got a low p-value. A low p-value normally indicates that it's not normal. Now granted, this is a low p-value on residuals, not on the regular data. So there's completely different, all right? So a low p-value for the residual data would actually mean not normal, where a high p-value would actually indicate normal. So you actually want something like this. You want a high p-value, and you want the data points to fall as closely to the line as possible. But remember, that is only for the probability, or only for residuals. That's not for like up here with the actual data. It's only down here for residuals. Also remember that the larger sample size will amplify things and make things seem more significant. So sometimes just having a really, really huge sample size can make things more significant than they really are. So it's just something to keep in mind, but that should be enough information to help you when we go through and you do this for your homework, your real data, and for the quiz.